So when we are dividing by a decimal, we're just going to move the decimal to the right to make it a whole number. And however many times we move that decimal, we also, on the inside, move the decimal that many times. Then once you have a whole number on the outside, you can then divide, and you don't have to worry about keeping track of the decimal at the end. Okay? I use some fancy words there. So this is the dividend. This is the divisor. And this is the quotient. If you're curious about where those vocab words are. So like 4 into 12. 12 is the dividend, 4 is the divisor, and the quotient would be 3. The quotient just means what's the answer to the division problem. Product means what's the answer to a multiplication problem. Sum is the answer to an addition problem. Difference is the answer to a subtraction problem. So, kind of small, but if we think about this one in terms of quarters and dollars. So if we're trying to figure out how many quarters are there in $6, how would we figure that out? Yeah.
4 times 6.
Yeah, because there's 4 and 1, right? And then 1 and 6. So basically you're just doing 4 times 6, which would be 24 quarters. Same thing here. 25 goes into 6. Or, sorry, 0.25 goes into 6 24 times. Okay? That's not how we're doing our division. It's just kind of help you figure out, you're trying to figure out how many times does this go into that. The real way, well, then we can do 25 into 600. So a little refresher here. Does 25 go into 6? Does 25 go into 6?
No.
Okay. Does 25 go into 60? 2 times, right? So we put that over the 0 of the 60. 2 times 25 is 50. Subtract, we get 10. Bring that 0 down. 25 goes into 100 4 times. 4 times 25 is 100. We get 0. That's kind of how we've done it in the past with whole numbers. Now we're doing it with decimals. So like I said on that first slide, all you do, and these would be good to be putting in your notes. You can start taking notes now if you haven't already. We're going to change this divisor by 1. We move the decimal 1 time. So there's a decimal here after the 18, so we move that once. So now we're basically doing 3 into 180. Okay? Does 3 go into 1? Does 3 go into 18?
It goes into 18
6 times. 6 times 3 is 18. Subtract, we get 0. Bring this 0 down. 3 goes into 0. 0 times 3 is 0. Subtract, we get 0. So 0.3 into 18 equals 60. Okay, so you take that decimal on the outside, on the divisor, you move it as many times as you need to turn it into a whole number, so it's not a decimal anymore. Then you go on the inside, it's called the dividend. You move the decimal on that one the same amount of times, and then you do your division problem. Okay, does that make sense?
So wouldn't that be 0.6?
No, because if we move this decimal at the beginning like we did here, we don't have to move the decimal at the end because we moved it on both numbers. So it's like, if you do it on both numbers, you're keeping the numbers equal to each other. The place value still stays the same. So it would just be 60. So how many times do we move the decimal on this one?
2.
So we're going to move it 2 times. So here we move it 2 times. So now our new question, which I'll rewrite, how many times does 5 go into 12,100? I'm going to get rid of that comma. It's going to confuse me later. 12,100. Answering this question is the same as answering our original question. We just moved the place value to make it easier for ourselves. So 5 goes into 12 2 times. 2 times 5 is 10. Subtract, we get 2. Bring the 1 down. 5 goes into 21 4 times. 4 times 5 is 20. Subtract. Bring the 0 all the way down. 5 goes into 10 2 times. 2 times 5 is 10. Subtract. Don't forget about this last 0 at the end. Okay? You have to divide through all of the whole numbers, all the numbers to the left of the decimal. If that 0 was to the right of the decimal, you can forget about it. But because it's to the left of the decimal right now, the decimal's right here, you have to bring it down. And then 5 goes into 0, 0 times 5 is 0. And so our final answer is 2,420. So this problem, think of nickels. Basically, we're asking how many nickels goes into $121. Well, how many nickels goes into $1? 20, right? And then if you think
Times that by 20.
you multiply 121 by 20, which would get you 2,420. So it might seem like it's a big number, but it is a big number because if you think of 5 cents, that's not a whole lot of money compared to $121, which is a decent amount of money. So a small number into a big number gets you a big number. It takes a lot of those small numbers to count up to that big number. Whew, it's a lot of words. All right, so it's kind of a bigger word problem here. So the boys ordered several pizzas for the weekend. After the first evening, the following amounts of pizza were left over. 1/4 of the pepperoni pizza, 1/2 of the cheese pizza, 3/4 of the mushroom pizza, and 1/4 of the supreme pizza. The next morning, each boy ate the equivalent of 1/4 of a pizza. If that finished the pizza, how many boys were there? So what's the question we're trying to answer?
How many pieces?
So x equals number of boys. How many pizzas were there in total that were ordered?
5.
Looks like there's 1, 2, 3, 4. And that's assuming they ordered one of each of those pizzas. They might have not ordered one of each of those pizzas, right? They're just saying like 1/4 of the pepperoni was left. So if they ordered four pepperoni pizzas, how many would be left? If they ordered 4 pepperoni pizzas and there was 1/4 left, how many pizzas would be left?
1.
Just one pizza, right? So we don't necessarily know how many, we just know the proportions that are left, right? So what we're going to do to solve this is we're going to add the pizzas together. So we'll have 1/4 plus 1/2 plus 3/4 plus 1/4. Change the half to fourths. So that's 2/4, add straight across. 3, 6, 7 fourths of the pizzas were left. So basically 1 3/4 pizza were left. Are we good so far? So the next morning, each boy ate, or basically each boy got 1/4. So you would divide that by 1/4, which would be 7/4 times 4 over 1, which would get you 7 boys. Okay? We good? You're going to have word problems like this on your homework, so it's important to know how to do these word problems correctly and accurately. Okay. Go ahead and read this one. So let's go through. So an average snowfall, what it means by average snowfall here is like just the basic consistency of snow. It's not talking like an average snowfall in a year of 10 inches. Okay. So he found that 5 inches of very wet snow, or 20 inches of very dry snow, will also melt to an inch of water. Okay? So basically we've got average snow is going to be 10 inches to 1 inch. top is snow, bottom is water. Wet snow is going to be 5 inches to 1 inch. And then dry snow is going to be 20 inches to 1 inch. Those are our ratios or proportions. Okay. So they got 5.3 inches of average snow. Then they got wet snow, which was another 4.1 inches. And then finally, they got 1.5 inches of rain. So we want to find how much water fell. So we know 1.5 inches of water. Yeah. Average snow, we got 5.3 inches. So that's 10 over 1 times, or equals 5.3 over x. Are we following that? We're saying we know that there's 10 inches of average snowfall per 1 inch of water. So 5.3 inches of average snowfall would equal how much water? So have we solved something like this before? Proportions? Ooh, fancy. I'm trying to think if there's a simpler way to show this than what I've done in algebra. I'm sure there is. Basically, it's going to be 10x equals 5.3. So you divide both sides by 10. You get 0.53 inches. So that is the average snowfall. And then for the wet snowfall, it's basically 5 times what number? N equals 4.1. So we would divide both sides by 5, and we get N equals, of course I don't have a calculator with me over here. Oops. No, stop that. 4.1 divided by 5, 0.82. Add all those together. You get 2.85 inches. So that one's a little bit trickier. There's probably a better way of showing that to y'all. I was using some pre-algebra stuff there because that's how I know how to solve these problems, is using some pre-algebra work, which we haven't quite got there, of this solving proportions, but I don't think there should be one that hard on work. There you go, another one for you to do. So the key here is you need to find the circumference of the first garden and then the circumference of the second garden. So remember, circumference here is 2 pi r. So it would be 6 times 3.14. So about 18.84 feet is the first circle. Then we have a second circle. What was the diameter of that first circle?
6 feet.
So what's the diameter of this one?
6 feet. Or the diameter would be
12, right? So then we can use the other circumference one here, C equals pi d. So C equals 12 times 3.14. And we get 37.68 feet. So the answer is going to be the difference between those two. 37.68 minus 18 and 84 hundredths. Yeah.
Well, when the radius squared is 9.
But we're not squaring it here. Edging means what's going on the outside. So it's the circumference.
Okay, that makes sense.
So it's like you have a garden that you want to put bricks around, is what he's talking about here. Next problem is going to be area. So here we're just doing circumference. So 18.84 feet is the difference. So basically he doubled the size of the circle for the circumference, that is. For the area, so remember first circle was 3 feet for the radius. Second circle was 6 feet for the radius. We doubled the size. So now he wants to fill in the garden. So this one took packet. What's that?
So we're finding the area.
Yeah, because now you're filling in the circle with seed, with grass, basically. Okay, so you want to find the area of these two circles. So the first one is area equals, sounds awesome, pi r squared. Area equals pi times 9, which was 3.14. So 28.26. This one, area equals pi 6 squared. So 3.14 times 36.
113.04.
Yep. 113.04. Says we can round the area to the nearest square foot. So we'll do, this will be 28 square feet. This will be 113 square feet. So what we want to find out is how many packets. So one packet covers how many square feet?
3.
No. It's a little bit of a trick question, but not much of a trick question. It's, no. It says 28 square feet. Because one packet was just enough to fill the area of the smaller garden. Okay? So if one packet can do 28 square feet, then we do 113 divided by 28. That would be 3, I think, is the closest we can get there. 3 times 28 is 60, 84. Subtract. That becomes a 0, 13. 9, that becomes a 0, 10, 29. Looks like we do 4. So 4 packets with an extra square foot left over, right? So how many packets would we need? 2. That came out of left field. So one packet covers 28 square feet, right? If we divide, what was 113 by 28, we found out that was 4. So 4 times 2, 28 is 80, 112. So that means it takes 4 packets to cover that whole area. 28 for the first packet, plus 28, which is now 56 for the second packet, plus 28, which is the third packet, plus 28 square feet, which is the fourth packet. Yeah? No? What's up? No, there's something that's not clicking. What's not clicking yet? you just saying that so I leave you alone? Okay. But there's 1 square foot left over, right? Are we just going to leave a bald patch in our garden? So what do we need to do? Add another packet. So overall, we're going to buy 5 packets. When you're doing real world problems like that, you have to buy more than you need so that you have enough to cover what you want. Okay, so if you're buying bark mulch for your garden or for your yard, you have to buy more bark mulch than you actually need if you can only buy it in like certain bags. Same with concrete, grout, anything you buy in bags, you always have to round up to the next whole number so that you have enough.